dynamic data that we would like them to, at least at this point. There's a good question about whether or not this gives us good coarse grainings. And good here is really application dependent. If you're a neuroscientist, it may be that these models give you really good coarse grainings, really good labelings on the graph because the underlying assumptions sort of match what the model does. That was the case with the malaria application. It may be that for other applications, though, the kinds of coarse grainings these things give you are crap, in which case you'd want to try to figure out how to adjust the model to find ones that are useful for whatever application you care about. That's a huge open area, and in some ways, there's an analog here between sort of block modeling or community detection in networks and clustering and vector data, which is a really old field. And there are several strong and somewhat depressing results in clustering. There's a great paper by John Kleinberg called An Impossibility Theorem for Clustering, in which he posits 3 very reasonable principles or axioms that you would like a clustering to satisfy and proves that you can only ever have 2. And so I think a similar kind of impossibility theorem probably applies to clustering in networks, although it's not clear how to translate the proof because one of the properties depends on having a metric, and there's no metric under these graphs. So I think that this question of good and coarse grainings is a really important and open one, but it's very technical, and it's not clear how even to approach that problem at this point. It feels like there's some symmetries between this and clustering, although that hasn't really been explored that much. And then finally, there's an even bigger question, which is how much does connectivity really tell us about about dynamics and function anyway? In practice, we often make the assumption that structure equals function. So we can find something interesting in the structure that implies something interesting about the function. But that's not necessarily true at all. It's an operating assumption. And we don't really have many examples in where we can actually test it. OK. So I promised to tell you a little bit about other things I work on. That's sort of a summary of some of the network stuff. I work on a lot of things, in part because they all have data